Thank you for joining us today to another Central Elevation webinar. I'm your host, Nando Mogollon. And today we will be continuing the last module of this series that is dedicated to the IFC special use cases. Now, if you did watch our last webinar on previous Tuesday, you probably went through the process of going in the first few steps to take over a design that is being handed over to you, typically from a company that uses Autodesk's Revit. In that case, we went through the process of calibrating the translation by using what it's called calibration files, which are kind of testing files, just to make sure that the things you're going to be receiving for the real project will be translated correctly in a way that can be reused for you to take over the rest of the design process. Now, within that context, and because these processes are quite lengthy, let's start right away with what we're going to take a look today. So for today, we have a review of the incoming IFC file, and where we're actually going to focus on the geometry validation. Now, before we jump into that, we're just going to take a quick review of the theory of this in case you don't remember what we saw the last time or just didn't have a time to catch it and missed it altogether. So we're going to take a quick view on that so that we're all on the same page in terms of terminology, or the terminology that we're going to use in this webinar. Then we're going to take a look at the dedicated translator we have created to take over that particular model. And at the end, we're going to check the resulting model geometry. Again, we're going to focus on geometry now, since data and information attached to models is quite important, but for these type of short webinars, we need to dedicate to specific items at the time. And geometry at this point in time tend to be much more critical than the data coming through, typically. We're going to focus on that stage on particularly the elements that will require some kind of replacement. Why? Because those tend to be the ones that will ask you to dedicate more time into the model just to swap things that were already created, just because you need to continue with the model changes and modifications. All right, so let's start with the bit of theory that we have in here. So the general process we're going to follow, rather quick and easy. We're going to take a model from Revit and save it as an IFC file, which is something we have done already because we're playing the part of the receiving side of the process. So we're taking an IFC file that was created from Autodesk Revit, and it's actually one of those sample files that comes with Revit. So it is very familiar for you if you probably have been looking other videos, or if you have ever used Revit, you'll see it and you'll recognize it right away. That particular translation, this one here, was done using two different model view definitions, which are kind of the different flavors of the IFC schema. Now, not all of them are the same, and since we're looking for taking over a model, we used IFC4 design transfer, which is particularly dedicated for that, and it writes geometry in a particular way. But we also used as a failsafe, we used 2x3 coordination view because we know what the resulting items will be. So it's kind of on the safe side, and we'll see what the differences are. Then we're going to open that IFC file in an IFC viewer, for which I'm going to use Solibri Office, but you could use Solibri anywhere. You could use some of the other IFC viewers out there. Solibri will do a particularly good job doing the things that I need to do, so that's why I'm choosing it. And within that, I'm going to focus, again, with the purpose of focusing on model and design transfer, I'm going to focus on finding explicit geometry and implicit geometry. For those of you who didn't catch our last webinar, we're explaining what the differences were in between those two. Generally speaking, in computer CAD geometrical type of software, Explicit geometry refers to the type of instructions that the computer will use to recreate something that looks like this based on a description of every single point and corner, edge, and face, so to build a volume or a solid. On the other side, implicit geometry implicates the reconstruction of the same geometry, but based on a series of instructions. Typically, you will recognize those easier to be things like extrusions, for instance, where what you have is simply the definition of a profile that gets extruded along a vector, producing as a result the same type of geometry, but based on a series of instructions. The two of them have different properties and qualities, and the resulting file may differ in how can it be used and what advantages are there to use either one or the other. IFC can write both and contain both sets of type of geometry, but for the sake of a model handover or a design handover, the more implicit geometry items we can get, the better, since that's going to allow the receiving software to do a better interpretation of the geometry only for the sake of reusing it. It might not be precise and exact to what it was looking like on the other side, but it will be one that you can reuse. When we transfer that back to Archicad, the IFC will take all these elements in explicit geometry and the elements in implicit geometry. And, because of the dedicated translator we're building, we're going to try to make sure that most of the implicit geometry, hopefully all of it, can be rebuilt inside Archicad with construction elements, meaning typical walls, beams, columns, slabs, roofs, and so on. And try to convert, which is typically an easy process and rarely fails, turn all the explicit geometry into objects or morphs, which are the sort of Archicad version of this type of geometry. So if we manage to get that through, we're going to get, as a result, the best result possible when bringing in a file from Revit to Archicad for the sake of a design takeover. Now, that being the case, let's jump right away and let's start with the review of the IFC within Solibri. Okay, so what we have here, this is probably the first time you see this, but this is the model I was talking about. It's a very common sample file that comes with Revit out of the box. We haven't done any modifications to it, so it comes as it is. And for the sake of testing, I did the two processes. And just to show you a little bit of the difference and why it's important to take a look at different IFC schemas before you even start the process. We actually tested the IFC4 with the model view definition transfer view as it comes out of Revit, and we actually hit some walls in there because you'll see that when I tried that, some of the geometry was missing, and it might have been an issue with the way the model was put together, because I'm aware that this is quite an old model. It was probably built back in 2012 or something like that. So it might have been a matter of, saving as, and then coming up with some issues there. I'm also aware that Revit, and that's something that we checked last week, Revit at the moment is not certified for IFC4 exports. So it does a pretty good job, but it's actually missing quite a few bits and pieces. And the reason why those bits and pieces are missing will be evident once we check the other one, the other IFC that I've converted there. So I'm actually going to use, because of this, I'm actually going to use IFC 2x3. Now, this one here actually brings in all the geometry, but the elements that are missing in the transfer view, model view definition, are missing just because they don't comply with the condition of being geometrically built with construction solid geometry or extrusions and implicit geometry. How do I know that? Well, if you remember from the last video, but I'll do it again, there is a way here in Solibri that I can find those elements and differentiate the elements that are built with explicit geometry from the ones that are built with implicit geometry, simply by looking for them in here. So I can type things like boundary, hit enter, and that typically will give me a quick view over the elements that have been built with boundary representations, or B-reps are they're also known, in the model. And coincidentally, these elements, like these exterior walls, the roof, that wall here, that wall there, those are the same ones that are missing in the IFC 4 model view definition transfer view. You probably can see that there. Like so. Now, I'm interested in those elements because I know that, for instance, some elements in here, like that wall, those two walls, this wall here on the side, they should have been built with implicit geometry, meaning some sort of extrusion or a profile and then an extrusion along the side. Now, that didn't happen in the transition from Revit to IFC. So there's no fault in Archicad. If Archicad cannot build this element as a wall, well, there's no way for Revit, for Archicad to do it, since the original geometry is not an implicit geometry. So when you have those type of errors, it is always good to go back and double check the IFC, since you'll, check that whether Archicad is doing something wrong or if it's just the translation from Revit to IFC. So that's that. Now, just to make it easier for you to identify those two elements, I've also built a way to separate the two. So within that model, what I have in here is there in orange, all the elements that are built in the IFC with explicit geometry. And what that means, and the reason why that is important to me, is that I will expect then to have all of these elements coming inside Archicad, either as objects or as morphs. But they will not be, say, roofs or walls, or I'm not sure what else, or a column like the one down here, and so on. And why is the case? Well, it's just the IFC element that is not built correctly. Now, at this stage, I'm not going to start an exchange saying, hey, can you rebuild this? There are ways to fix this, but let's assume, because I know that some of you might be finding yourself in this situation, let's assume that this is what we get and we're not going to get anything better than this. So let's see how can we take over this and continue working with the file. At the same time, the good news is that all of these other elements I've got in here, and that's the majority of them, they have been passed on from Revit to IFC with actual implicit geometry, meaning that these things, these elements here, will follow an extrusion. And you can tell those, oh, there's different layers in there. You can tell those because they actually are called extrusion geometries within the information panel inside Solibri. So anyway, this just gives you a quick overview over what's the potential of the model once you bring it into your Archicad file. All right, now let's go and take a look at Archicad. And on the second step, we'll look at the translator that we have built, which is essentially the same one we used the last time, with a few additions to materials and a few other things. I'll show you what the differences are. All right, now, and once again, because we only have like half an hour on this, I've already done the hotlink, and it is a hotlink. And the reason why it is a hotlink is because I want to be able to fine-tune the translator before I actually merge it into this new file. So the translator will allow, the hotlink will allow me to refine the translator and update the hotlink. That's going to change the conditions of the transfer, of the translation. So what I've got here is pretty much something that looks like the same file. I actually have brought in things like the interior furniture that includes a bunch of things that I may not need to use, but I'm just going to take it over as it is. And let's take a step back. Actually, let's do this. And one thing that I've done in here is create a dedicated translator based on the calibration file. Now, the calibration file, as you remember, was an empty file that received a sample model of every type. And then with that, we pretty much fine-tuned a translation for different items, particularly for geometry conversion, layer conversion, and material and surface conversion. Why? Well, as you know, the purpose of this is to take over the model as it is. So layer conversion was done, as you remember this, as an actual mapping from whatever the layers I could find inside the IFC by clicking this Merge from IFC button into my current files. Now, you'll note here that what I'm using is essentially the Australian basic template that comes out of the box. No magic into that. I'm just using it for the sake of bringing the file as it is. Materials and surface conversions, similar thing. I've made sure that I could do a mapping, and I will take over every single material coming from the Revit file through the IFC and turn those into my standard building materials as I have them in my template. Again, because I want to keep this within the context of my own standards. One extra thing I did just to make sure that things looked kind of similar to what they looked in the original file. This time I actually have overridden the material colors, meaning the Archicad surfaces, with whatever surfaces were written in the IFC file. Now again, IFC file, technically speaking, it's capable of containing information about finishes, textures, and so on. But currently, it's only been implemented to carry on RGB information, therefore is essentially just colors. So as a result of this, in your incoming Archicad file, you'll have additional building surfaces, not building materials, surfaces. And we're going to take over those and apply them as we need to. So let's click on OK. And geometry conversion, nothing weird in here. You can use either objects or morphs for those explicit geometry items. I think at the end I've chosen morphs, but might have been different. But the important thing is that building elements should go to construction elements as much as possible, otherwise either objects or morphs. The difference between the two, as I mentioned the last time, typically morphs will give you a better time in terms of the capacity for you to quickly modify the elements at the expense of losing a little bit of the performance on your computer. If you go for objects, you're going to gain performance, but then you won't be able to modify the element as if it was a morph, pushing and pulling and so on. But it will create a file size that is slightly bigger since it will create every single item or element as an object. And even though they're quite small in size, they tend to accumulate with time. Everything else is pretty much the same as we explained with our calibration file, including the important profile attributes, meaning that you should create new attributes so that you can take over those. Okay, I didn't do anything more than that. I just adjusted layers and materials mostly, and I'm going to keep the model filter on, which is going to allow me to do things like switching off those glasses and furniture if I don't really need to bring that in. So I'm going to leave it as it is. That's a file that I want to play with. And let's take a look at what happened after the translation. So the first thing that I want to show you here is the implicit geometry as it came through. Now, if you take a look at this and compare this view roughly with my view here, you'll see that the two of them are pretty much the same, meaning that the implicit geometry as it was found in Solibri, so directly from the IFC, and the one that I've got here in Archicad are quite similar. Now, what I've done there is just apply a graphic I just applied a graphic override where I'm essentially just trying to find elements that are either built with all the construction elements, rather not morphs, not objects. That's what this condition is doing. And then that's going to turn them in green. Otherwise, they'll be orange. So that's essentially what I did here. One thing has changed though, and that's the one of those that I want you to be aware of. Most of the elements I'll be able just to take over and keep using them because these are, floor slabs that are actually being built with a slab tool and coming in with a proper attribute, in this case, a composite. They already landing in the right layer that I've chosen for them, and they have the right classification. So easy for me just to take over that without much modification, other than adjusting, line weights and some other things. Even this element in here, which is an actual wall with a bunch of cuts through it or trims, it has come through as an actual wall with a composite. So that is possible. One thing that didn't come through though, and I'll show you that here in the explicit geometry filter that I've got here, is, well, the roof and walls on the sides that I was already aware of. This wall in here that somehow doesn't want to come through as a profile in the IFC. But also, and this is quite interesting, and this is something that could be done better if computer power allows in the future, the curtain walls typically do not come through as explicit geometry. So rather, you'll see that here, that every panel and frame tends to be built with either morphs or objects, even though the IFC recognizes those things as to be extrusions. And again, that's usually due to the nature of the two different tools, both in Revit and the way Revit builds a curtain wall and the way Archicad will recognize that and build its own curtain wall. So at the moment, they come through as simple objects or morphs, and Archicad won't build a curtain wall in replacement of that. So that's one of those that are, kind of better if it was different, but it is what it is. And we can actually go and simply replace it with our own tools. Things that I wasn't expecting to be built with anything other than objects or morphs, these particular objects like this chimney here or the railing, similar situation as with the curtain wall. Even though Archicad has a pretty good railing tool, it won't be recognized because, well, to begin with, the IFC didn't have that as an extrusion or as a implicit geometry. Okay, so that's implicit geometry and explicit geometry. Implicit geometry, you can translate this into things that I can just take over and carry on with those. Explicit ones are the ones that you're going to say, all right, I'm going to have to build my own things out of those. But in reality, you don't have to build everything out of this. You just need to take over the elements that should be extrusions but are not. For instance, let's go take a look in here. Actually, let me get rid of the overrides so that we can focus on individual items in here. For instance, if I take a look at what's going on down here, I don't think I will translate these chairs and tables or these joinery items that are already there, because they're pretty good and I can just reuse them. I can probably tweak them and make them a morph and give them the finishes that I want, but I really don't want to rebuild those unless I really need to, change the kitchen completely. Rather take over those as they are. So these are objects or morphs that will come in as objects, and I'm probably going to keep them as objects as much as I can. On the other side, as you know, we have the issue with, for instance, the curtain wall, which I actually want to rebuild. So there's a difference here in between the two types of elements that I want to take over. And for that, I'm going to focus on the following objects. For that, I have this view here. Now, this view, the only thing that I've done with that, it's simply to highlight with a graphic override the elements that I actually need to replace. And those are elements that came through as objects or morphs, but they're supposed to be construction elements: walls, slabs, columns, curtain walls, etc., etc. And that's going to help me in the future simply to do a replacement of those. Probably the most critical one might be the curtain wall, since it will ask you to rebuild the entire the schema of the curtain wall. So that's the full description of grids, mullions, and transoms. But other than that, typical walls and slabs, they tend to be rather quick. All right, so that up until that point, how do I see this, or how does this translate back to a plan view? Because that's probably one of the critical things that you guys are going to ask me. Say, hey, that's all fine, but in reality, unless I can reuse these for my own drawings, they'll be useless. There are a couple of things in here that I want to just to remind you that they happen in a particular way. When Archicad builds these elements and it gives it a plan representation, for those elements that are already an implicit geometry, like this wall in here, the wall comes through with its own building material and comes through with a composite if it has a composite. For instance, that's just a simple building material, but I am aware that, say, this one here comes with an actual composite. Now, because I've done the translation already, and I've said, hey, recreate an actual attribute for all of the elements using the same type of wall, I can then just go and take over the attribute, because this particular attribute belongs to my file, doesn't belong to the IFC. So I'm still capable of going in here and change the line and pen assignments and building material assignments if I really needed to, right? Because sometimes, you'll never know if the building was put together correctly on the other side. So there might be some adjustments needed to be done. And particularly the line weights. I'm, really not keen to keep all these lines in pen number 1, because I'm actually using the standard pencil tables where I have assignments for those, probably those walls on the side. I'm going to choose a pen on the wall, the column dedicated to the walls, or the ones that if you have deviated from that, then you choose the correct pen. But they'll require some adjustment, but you don't need to rebuild the wall. The wall just comes through and you just reuse that and adjust those attributes. That's for those. Now, the elements, and the same thing will happen. For instance, there's an opening here, and you may not want to keep the opening with that particular symbol. Once we merge this file into my file, I can just swap it and make it look in any particular way. Or if you want to change it based on the link, you just have to update the link, making sure that your current and default opening tool will have a default symbol view that actually matches what you want to keep. So for instance, I can choose no symbol, click on OK. That's going to be my new default. And if I just go ahead and update this hotlink, this symbol will disappear and will be replaced by the default one. Same principle will apply for every other object that I have in here. For instance, this one wall in here, which I'm pretty sure at the end it's going to be the same as that, sort of mirror to this side, of course, but it should be looking the same. Now, this is one that came as an object, so I'm going to have to replace it. And I can actually, let me double check that. Just highlighting things in plan view, that'll be a similar thing. Let me do this quick. Let's say something like that, just to quickly highlight the elements that will require replacement in plan view. So with a view like this and a graphic override, easy to pick, I now know which elements should I go and replace. And as you can tell, sure, there are some of them, they're not all of them. So that will give you a quick view over what do you need to replace in order to take over and carry on with this design without having to rebuild the entire thing. All right, so it is time. We went over just a couple of minutes, but I hope that, quick example, it's been useful. Please, if you have any questions and you want to type them there in the GoToWebinar panel, feel free to do that, and we'll send you a reply over email. If not, please join our next webinar. If you don't know when is that going to happen and how to subscribe, just point out your cameras, on your phone cameras, into that QR code that's going to take you to a website, or just type that website as you see it there on the screen. That's going to take you to the website where the calendar lives, and that's going to allow you to subscribe to any coming webinars. Getting help in Australia and New Zealand through the support hotline right there, or just logging in through myci@centralinnovation.com. That's going to allow you to log in tickets and ask questions as needed, or via the support emails as they're sitting down there on the screen. So don't forget to register and check the rest of the content we have in there. There's a bunch of things coming new in the portal, so go check it out and stay tuned for next webinar. We will be continuing with this series. Now we're going to start jumping into other special IFC use cases. We're going to try to cover most of the common special use cases like sequencing and costing and structural exchanges. And hopefully by the end, we should be able to get on to delivery for record and asset management as much as we can and times allows. Thank you very much, and I'll see you next time.